Hi ECU students, welcome to week 4 of Business 426 in Production Management and Operations. Hope things are going well for you. Here's what we're studying this week. We're going to be looking at this concept of total quality management. We're going to be looking at Six Sigma, which some of you may have heard about, I don't know, maybe not. Lean production systems, I'm thinking probably most people have heard about this by now, maybe not. And then we're also going to look at logistics, distribution, and transportation. And these are all scattered throughout the chapters that are assigned for this week. So make sure, when I do these overviews, these are not meant to be comprehensive and really in-depth, or more or less just a skim over the top. Make sure you read the chapters because that's where the quizzes come from. The details for the assignments and the discussion questions come from that as well. Let's talk about total quality management for just a second. TQM, it's a short name for it, came around in the mid-80s actually. And it's about managing the entire organization so that it excels on all dimensions of product and services. So it focuses on a couple of the areas. One, careful design of services or product. So you design product or service so that it's not so big that you can't do it, but you design a great product or great service that you can deliver all the time, each time. And part of the TQM as well is ensuring that the organization's systems can consistently produce that product. So time after time after time, whether it be a McDonald's hamburger, service like in a grocery store or a department store, a retail store, or manufacturing process, can be consistently built or delivered to the specifications of the service or product that was designed. The idea of cost of quality is built into total quality management, or TQM. So quality does have a cost. It is not free. And these are a number of different categories that discusses a different cost of quality. One of them I just want to talk about real quick. I'll let you read about the other ones, but this prevention cost. Sometimes we don't think about the prevention cost of quality. And it's the sum of all the costs that actually are preventative that your organization does. So think about it for a minute like this. If you're in a business and you focus a lot on doing a right design or right service so that you can produce that thing the same way all the time, that's a preventative cost. You're preventing a quality issue from happening by making sure the design is correct up front. So that's an example of a prevention of cost. Cost of quality is big in the industries where I work. And in most manufacturing industries, whether it be automotive or shoes or food or agriculture. So make sure you read that section on cost of quality. Six Sigma. It's a philosophy actually. Been around for a while now, and it kind of refers to the goal of no more than 4 defects per million. Now, this is kind of a literal interpretation. So imagine, a million hamburgers made by McDonald's in whatever time period that is. Only 4 of them could be defective. And defective might mean a number of different things. Maybe it didn't get mustard on it. Maybe it didn't get ketchup on it. Maybe they forgot the pickles, whatever it would be. So 4 out of a million. If they delivered no more than 4 bad hamburgers out of a million, they would be Six Sigma capable. That's a lot. Think about the shoes, think about cars, think about parts, think about packaged food. Processes that are Six Sigma capable deliver no more than 4 million units of defect in a certain time period. I do have some videos I attached in the extra materials section. Make sure you check those out because there's a lot in there about Six Sigma, Lean, and some of these things we're talking about. Some of the tools that we use in Six Sigma to measure how we're doing are run charts, for example, over a certain time period. What is in this case, volume, what's the delivery, what's the service, whatever thing that you're measuring this is called a run chart. Pretty simple. You can see all the variation from low to high during this time period. You might want to check out why there's that variation. You might want to check out why this thing started dipping again after a few months. Check sheets are pretty popular. In this case, it was there's a particular machine. It keeps going down, keeps shutting off, or they have to keep shutting the process off. This measures all the potential reasons, and in this case, it's just a hand chart that an operator ticks, does the five check tick marks to find out why. Carton transport, whatever that is, seems to be the most popular reason why the machine is going down. This fishbone diagram, the formal name is an Ishikawa diagram. cause and effect diagram is how we say it in English, but it looks like a fishbone diagram. Real quick, you put the problem, get my cursor over, you put the problem in the box here. In this case, it's late pizza deliveries on Fridays and Saturdays. And there are always 4 branches, bones if you want to call them that lead into any kind of problem. And the 4, no matter what the problem is, you can usually break the problem down into man or people issues here, as you can see right there. So man, machine, material, and methods, and then material. And this is not highly technical. This is meant to be kind of messy, but you can see, like, in the area around people, there's no teamwork. There's no teamwork because there's no training. People don't show up. Well, why don't they show up? Because there's low pay, there's high turnover. You get the idea. When you get done with this, you kind of like, seriously? You squint at it. Where's the highest density of all the text and the work? It's right here on this people issue. So if I was going to attack this problem, I'd be attacking the people issue first. I'd probably do materials last. Doesn't seem to be pretty dense with anything. So there you have it. All right, lean production. Not going to hit all these like I said, during this overview, not going to hit this in depth. Just know that lean production is an integrated activity. Like, the whole organization is involved to design to achieve some high volume production of, could be a product or a service, using minimal inventories. It's all about eliminating waste, reducing waste. There's a couple of slides or a couple of videos I have in the materials section, extra materials section for you to watch about waste and material. Waste, and there's 7 different forms of waste, so check that out. And also, lean, pretty important concept here, is customer value. It's something that the customer is willing to pay for. So when you look at your process at work, if you're doing things that the customer isn't willing to pay for, you're probably not ought to be doing them. All right, so the logic works like this in a lean manufacturing environment. I'm going to jump to the next slide real quick, but basically, when a customer orders something from a factory, from a service, or from a kitchen, it creates an order, and then everything else behind it gets ordered up as well. So for example, let's say you got a pair of tennis shoes sitting on the dock at the Nike factory. Customer orders a pair of them. Those get shipped. That empty spot where the shoes were sitting, and I know I'm breaking this down to real simple, creates an order. That empty spot creates an order to the 2 sub-assemblies or 3 or 4 sub-assemblies that are used to put those shoes together. Maybe it's the soles, maybe it's the liners, and that in turn generates other orders in the factory all the way back to the suppliers. Ideally, this is one piece flow all the way through the system. You don't build up huge batches of inventory in between all these different processes. Remember, inventory is like money sitting on your floor doing nothing. It's not in the bank. It's not in your coffers generating more interest for you. You can't do anything with inventory except for sell it. So be careful not to have a lot of inventory on your plant floor or in your kitchen or in your service organization, wherever you work. Inventory generally is bad. Okay, a lot of inventory is bad. This idea of quality at the source has to think about like this. You want to do it right the first time. If something goes wrong in the process and you start generating scrap, non-conforming material, stop the process right now and go fix it. You're miles ahead by stopping right now, going to fix it, then you are to keep generating bad product, hoping to fix it later on. In this concept, workers are personally responsible for the quality of their output. They're their own inspectors, and they're empowered to do their own maintenance. Okay, that's it. Make sure you read chapters 12, 14, and 15. Get the discussion questions done by Wednesday evening, and your responses to those on Sunday. Quizzes are due on Friday night. And again, assignment due on Sunday. All right, have a great week.